Alright, good morning students. I'm going to make another video specifically just about parallel lines cut by a transversal and breaking down the different types of angles within them, all written out here on the screen, so there's no excuse for not knowing which is which. You need to have these memorized. And then we'll review some angles down here, linear pairs and vertical angles as well, where we see them in the drawing up here as well. Alright, if you notice right down here, we are starting with parallel lines. We know that these two lines are parallel by the blue arrows. Okay? So this is what we're starting with, parallel lines, M and N, cut by transversal K. Remember, naming lines can be done by any 2 points on the line, which we don't have any points labeled, or by a lowercase letter near one of the arrows, which we have in this case. So this is the common drawing you will see. The transversal could go like this, etc. Okay, it doesn't matter. Okay, so within this, we want to think of these four types of angles: alternate interior angles, AIA, alternate exterior angles, AEA, corresponding angles, often just simplified down to CORR for corresponding, and same side interior angles, SSI, also called consecutive interior angles in some books, like it is on that worksheet you have for homework. All right. The next key words that we have in here are interior, exterior, and alternate. I stands for interior. It means inside. Interior means inside, so we're talking about inside the parallel lines. So angles 3, 4, 5, and 6, as we have listed here. Exterior means outside, so it's outside the parallel lines. Angles 1, 2, 7, and 8. And alternate, I want you to think of as diagonal across the transversal. So example, 3 and 6, 4 and 5, 1 and 8, 2 and 7 are the key angles that we're going to be talking about when we're talking about alternate. Okay, diagonal across the transversal. All right, so let's go ahead and identify each of these pairings within these four types of angles we have here. Alternate interior angles. You see it has to be interior, so it has to be angles. I can only choose from angles 3, 4, 5, and 6. These are the only interior angles. Alternate, as we just got on saying, means diagonal across. So now that's a dead giveaway. 3 and 6 right here, and 4 and 5, done deal. Alternate exterior, so they have to be exterior angles. That's only 1, 2, 7, and 8. Alternate means diagonal. 8 and 1, as we see right here, and 7 and 2 right there. Two pairs. Corresponding angles. Corresponding is the hardest for people to remember. Corresponding means they have to be on the same side of the transversal. So if I'm talking about a pair of corresponding, I can only choose from either 2, 4, 6, or 8 if I'm choosing this side of the transversal, or I can only choose between 1, 3, 5, and 7 if I'm on this side of the transversal. They have to be on the same side, one side or the other. And then one angle has to be outside or exterior, one has to be inside, interior, and they cannot be adjacent. So it cannot be 1 and 3 because those are adjacent. So an exterior and interior, 1 and 5. The other pair is 3 and 7. We do the same thing on the other side. Exterior and interior on the same side, but not adjacent, so it can't be 4. So 2 and 6, and then 4 and 8. And we have all these listed right here. The last type of angle, we have a same side interior. Again, it tells me interior, so I can only choose between these four, and it says same side. So not alternate, not diagonal, the same side. 3 and 5 is one pair, 4 and 6 is the other pair. Now notice with the first three pairings, the first three types of angles, alternate interior, alternate exterior, and corresponding, all of those pairs are congruent, which also means, congruent means the shape is exactly the same. If it said equal in measure, like the measure of the angles are equal, that refers, so if you use an equal sign, that means the angle measure is the same. Now, if two angles are congruent, then they will be equal in measure by the definition of congruence. I put that in there right now, so when we get to proofs later on, and if we talk about two angles being congruent, then we can, next step, we can say those same two angles are equal in measure, put that M in front of the angle symbol, and this would be our justification, definition of congruence. Anytime we have congruent angles, or congruent shapes, then those angles be equal in measure by definition of congruence. That'll come up later with proof, so I'm just throwing that in there right now. Okay, our last, so these first three pairings, types of angles, all the pairs are congruent or equal in measure. But the last one, the SSI, the same side interior angles, 3 plus 5 adds to 180. What does it mean if two angles add to 180? What's that vocab word? You should recall that already. We've used it. Down here, supplementary. You need two angles that add to 180. So 3 plus 5 adds to 180. Now that should make sense because if we look at this one, 5 looks just like 1. Remember, 1 and 5 is one of the corresponding angles, so they're equal in measure. And we know 1 and 3 are adjacent in supplementary because they form a linear pair. And we know all linear pairs from before are supplementary since they add to 180. Okay, so if 1 equals 5, and we know 1 plus 3 equals 180, then 3 plus 5 has to equal 180. We'll get into proofs with that later on. Okay, and the other supplementary one, the other same side triangle, 4 plus 6 has to equal 180. So those two are supplementary. Now the easy way to remember which of the four are supplementary is there's only one of these here, as you see here, that has the word S in it, a letter S in it. And obviously supplementary starts with an S. So same side triangles must be supplementary. It should be easy to remember. The other three types are all congruent, which means they're all equal in measure, the pairings. All right, so now let's look at the linear pairs. This is review. Okay, so this is not usually associated with, when we talk about parallel lines cut by a transversal, we're usually referring to one of these four types of angles, but these are all true. They're all within these drawings as well, but this is review. You usually have learned this first. So we've already learned about linear pairs, so I just listed all of them. 1 and 2, 1 and 3, 2 and 4, 3 and 4, 5 and 6, 5 and 7, 6 and 8, and 7 and 8. All those form linear pairs, which means they add, each of those pairings add to 180. Supplementary two angles that add to 180. Now don't forget, linear pairs, these angles also have to be adjacent. Every one of these are adjacent supplementary angles, which means they are next to each other. Remember, adjacent means next to. And then they form a line. Each of these, put 5 and 7 together, it forms that line. 5 and 6, it forms this line. 6 and 8 forms this line. 7 and 8 forms that line. Okay, linear pairs always form a line. They're always supplementary. We know all lines are straight angles, 180 degrees. And lastly, our other type that we have here, let's review as well, are vertical angles. All vertical angles are congruent, which, as we just said up here, if they're congruent, then they will be equal in measure by the definition of congruence. So what are vertical angles? Remember, they form two V's. If you think of it that way, that share a common endpoint. So 1 and 4 is one pair, 2 and 3 are equal, 5 and 8 are equal, and 6 and 7 are equal. Here's all of our listings right here. Okay, so these are all the different types of angles that we can even associate with on parallel lines cut by transversal. And this is when we start with parallel lines being true, that these two lines, M and N, are parallel. Okay, so let's go to the next page. Now you have what we call the converse of in the different theorems. Converse of is always used at the beginning in most books. The book that has the worksheet on it, they actually put the word converse at the end, but most put it at the beginning. It has to have the word converse in there, though. Converse of. When we're talking about converse of, this is when we know a certain pair of angles are true, are congruent or supplementary. Then we can say that the two lines are parallel. Notice I do not have arrows on any of these two sets of lines. That means we do not know they're parallel yet. So when we're talking about using converse of in one of our justifications, okay, so it's converse of the corresponding angle structure. If it's using converse of, that means we're trying to prove the two lines to be parallel. We do not start with them being parallel. Remember, on this first page, we started with them being parallel. We knew they're parallel. Then we can make all these statements. Well, here we're going to know one pairing of our angles from the last page to be true. Then we can state that the two lines are parallel. So this is how you prove two lines parallel when you have two lines cut by a transversal. So our first example says if two lines are cut by a transversal and angle 1 is congruent to angle 5. Okay, well, you should remember from the last page that angle 1 and angle 5 are corresponding angles. Now, it doesn't just have to be 1 and 5. It could have been 4 and 7, 2 and 6, or 3 and 8. Any of our pairs of corresponding angles. If we can show one pair of those corresponding angles is congruent, then the two lines are parallel. So on the park, it will say if two lines are cut by transversal and corresponding angles are congruent, then the lines are parallel. If you are shown a pair of corresponding angles being congruent. So let's go ahead and show what that would look like if angle 1 was congruent to angle 5. Remember, we use arcs. So if you have that scenario, the justification on your test And on the park would be what we have here in the green. Here, notice if we have two lines are cut by transversal and angle 4 is congruent to angle 6. So we have that scenario. That one is congruent to that. Remember, congruent would also mean that they're equal in measure. So remember, these are alternate interior angles. So that's why it says the converse of the alternate interior angles theorem. Now, on the quiz or test in class, I will let you write what is in red, the actual name of the theorem or postulate itself. But as I told you on the park, it will always write out the full definition of that. So we'll not have converse of the corresponding angles postulate. It will write out this whole thing, what we have here in green. Because again, some books call it different order. Like I said, some books will put the converse at the end and people will get confused. So in order to not deal with confusion of different vocab or how it's written in some books on the park, they just go ahead and write out the full definition that you would be choosing from. This would be in a multiple choice or drop down menu to choose from, multiple choice. All right, so since 4 and 6 are alternate interior angles, that's why this is called the converse of the alternate interior angles theorem. If we know any pair of alternate interior angles are equal, now we can say that these two lines are parallel. So it could have been either 4 and 6 are congruent or 3 and 5, my two pairs of alternate interior angles. Okay, the next one, converse of the same side interior angles theorem. Well, if you remember from the last page, same side interior angles, they are not congruent because it starts with an S. The same side interior angles must be supplementary, which means the two angles just add to 180. That's why you see that here. If two lines are cut by transversal and angle 3 plus angle 6 add to 180, then we can say that these two lines are parallel. Or it could have been if angle 4 plus angle 5 add to 180, then the two lines are parallel. So if two lines are cut by transversal and same side interior angles are supplementary, notice the other ones say equal, or they might say congruent on that part, then the lines are parallel. Okay, and lastly, we have the converse of the AEA theorem. Remember, AEA is alternate exterior angles. So if two lines are cut by transversal and angles 2 and 7 are congruent or equal, then the two lines are parallel, and now we'd be able to put arrows on these. Okay, so it could have been either 2 or 7 or 1 and 8, the other pair of alternate exterior angles. All you need is one pair to be congruent. Okay, so recall again, 1, 2, these three right here. Any one pair of the angles must be congruent, and then with same side interior angles, they must be supplementary, adding to 180. So if it said angle 3 equal to angle 6, that's not true. That's not same side interior angles being supplementary. It must be congruent. I mean, it must be supplementary, but they must add to 180. Do not forget that. So this page, let me go ahead and put in the 2 and the 7 in here. So if we know angle 2 was congruent to angle 7, or it could have been 1 and 8. I'm just showing you one pair, but either pair. If one of those pairs is congruent, then we can say that these two lines are parallel. Okay, and our justification will be the converse of the AEA theorem. So you will get into that with proofs later on as well, or just making those statements. So you can see any of this on your quiz and tests coming up this week. You'll have a quiz when we come back from the 3-day weekend here, unless upcoming hurricane tells us we don't have school. All right, enjoy your 3-day weekend. Goodbye.